Ya mimi nianzishe.
Hi Phyllis, can you grant me rights to share the screen?
Yenu walifanya introduction, muliingia tu direct to class. Ni-
Good afternoon. Good afternoon. Just to clarify, are you able to hear me clearly?
Yes, we can hear you.
Okay, okay. Okay. So Phyllis, maybe you can take lead, or I should just go ahead and start.
I was suggesting maybe we could like give them an
A
extra
few more
4 minutes.
minutes.
Yeah,
Okay,
and
that's
then we
fine.
can
That's
start.
fine. Okay,
Okay.
thank you, Phyllis. Thank you.
Hi, Joseph. Maybe we could start.
Okay. Sounds good. Thanks. Good afternoon, folks. So my name is Joseph, Joseph Ridge. I'd like to welcome you to the first session, an introduction to backend development. I'll be your trainer, and welcome. So just to confirm, I'd like, since it's 6 of you, I'd like you to give me one statement that tells me talk about yourself, besides what you do, where you work or where you study, and not your name. So we can start with Dorothy. Dorothy, the floor is yours. Lauren, Jacinta, Ezekiah, Joseph, Chris, Geoffrey. Tell me something.
Hi everyone. So I'm not supposed to say my name, right?
No, you're not.
Okay, yeah. So I'm a backend developer. I work for Biashara Africa Limited. And
Not even what you do.
oh, what's it? Okay.
Even not
So,
don't tell us about what you do nor where you
uh-huh,
work. Just tell
uh-huh.
us something about yourself, but it shouldn't encompass anything more what you do or where you work.
Okay.
Something different, something interesting.
Wow, something interesting. I I love reading.
Yeah.
Fiction. Yeah, fiction. I can stay up a whole night reading a book, and I love cooking.
Oh, awesome.
Yeah.
Nice one. Jacinta, your turn.
Hello, everyone. I'm trying to think of something. uh, okay, let's talk about what I do when I'm not working and I'm not studying. So I like podcasts. I like
Ah,
music. Music locally, I like Nyashinsky. I
yeah.
like Rikita. Okay,
Nice.
I can't think. And South is all. So
So,
basically, that's where I spend most of my time. Podcasts, music, and some series, some drama series. Okay, that's all.
awesome. Awesome. That's great. Nice one. Hezekiah?
Hello everyone. I hope everyone can hear me.
Perfectly.
Yeah. So I like listening to music, but most importantly, I like playing chess, specifically bullet. So
Yeah.
chess has different levels. So I play bullet is where you play with someone, but under 1 minute. So that's what I like the most.
Oh, under the gun, I see. Joseph?
Yes, hello everybody. My name is Joseph. It's something interesting about me. I like sports. I I support the Arsenal club.
Nice.
Yes, and yeah, I also play basketball. And yeah, I have interest in backend and DevOps. This course fits my personal needs. And I'm from South
Awesome.
Sudan.
Awesome. Welcome to Kenya, virtually, I guess. Chris, your turn. Chris. Geoffrey, you can go to Geoffrey as Chris prepares.
Yeah, good afternoon. So I'm learning how to play a guitar and also love listening to podcasts.
Who?
I'm learning how to play guitar and also love listening to podcasts.
That's awesome. That's awesome. Nice. Dorothy and Chris, it's your turn.
Okay, hello. Am I audible? Hello?
I can hear you. I can hear you. Awesome.
Okay. For me, I like exploring nature. I like hiking, and also I like watching movie series on sci-fi. Basically, that is about me.
This is really good. This is really good. Awesome. So now you're about to start. Phyllis, do you have something to say? Maybe introduce yourself.
Okay, thanks. My name is Phyllis, and I'll be helping Ridge to coordinate the session. But Joseph is the trainer. Yeah, thanks. I don't think I have much to say.
Thanks. Thanks, Phyllis. Phyllis is our top password here. And if you have any challenges or any concerns, you will help us with our queen over here. Thank you, Felix. So I'm going to hit it straight. And my assumption would be, I'll just start off by asking, how many have a background in programming? That's the first question I'd ask. You can just raise your hand. No need to, or even just shout. Or you just raise your hand. I get a time. 3, 4. Okay. 4 is a good number. So, okay. So we're going to do this. We're going to do this. I'm going to tell you a story because I'm sure one thing that majority of you did, or rather went through, is you started to learn how to code, or rather you started coding, but then you didn't learn how it works, or rather some things, how some fundamental things work. So I'm going to tell you a story about the internet, and you're going to progress from the internet all the way to the backend. Are we together, folks? So the backend is a very fancy word. It looks like something very server side. What coin it as? So before I proceed, I encourage you to ask as many questions as you want. In case of any challenge, in terms of the content or not understanding, shout out. This is an open space. I will answer it to the best of my knowledge. If not, I will research and help you solve it. In terms of bugs, we'll handle the bugs together in the event that you encounter bugs in the future during your development. And yeah. So let's kick it off. I'm going to tell you a story about the internet. Fun fact. It's weird how majority of these developments only start up at an army level, an army research level. So let's start. So you find one. The internet was basically started by in the 1960s by the US Army as just a research project before they gave it out to the public. So I want you to follow through my thought process. Okay, we are going to go step by step till we get to the backend where the meat is. Okay, so we're starting off with the internet. The internet is just a backbone of the web. The web is just a fancy term. Think about connected computers. Think about I can connect your machine to her machine to their machines and communicate with them. But again, how does it really go? Let's find out. So this is an example of just a rough figure of what the internet was. If you look at this, I hope you can see my screen. Just confirm you can see my screen. You can shout out. Yes, it's fine. Can you?
Yes.
Oh, sorry. So in this scenario, I want you to look at this. Think of the internet as a line. This line you see here. So this line, it's more or less like that fiber optic cable or that internet cable that passes underground, and it connects more than one, or rather close to more than one entity or machine. So that is what the internet basically does. You have the whole line here, and you have computers connected to it. In this case, in this scenario, it's a server. Okay, we'll get to know what a server is. So just go with me. Go with me. Are we together, folks? Till that point, are we together, guys? Awesome.
Yes.
Excellent. So now, a server is an interesting thing. It's a very fancy word. It's a very fancy word. It's like a buzzword. You go out there, you say server, people start saying, "Oh, this is the computer guy. This is the computer guru." Okay? Now let's simplify it. Let's simplify it. A server is basically a computer that runs somewhere in the cloud. This particular computer serves the purpose of either controlling a process, serving a process, controlling a process, serving a process, or hosting your database and providing and finding ways to expose that database to other applications. Okay. Does it make sense now? Does it make sense, folks? Yeah, we'll continue. So here you find there are millions and millions of servers out there, close to billions plus. I think even twice the population itself. So what you tend to find is it's really difficult to identify a server from another server. So what we usually do is they contain what you know as internet protocols. So these internet protocols are like a series of numbers separated by dots that are able to identify a particular server or computer. So this is an example of an IP, what you see here, 72.14.205.100. So this particular IP, very simply put, it's very hard for me to cram this, or rather very hard for me to always pull this out from my memory immediately, considering there are millions and millions of platforms I know about. It's Facebook, look at Facebook, we look at WhatsApp, we look at a tyranny, a whole plethora, if I may put it, of platforms you can access. Are you together till there, folks? Hey, people, are you together? Liam, are we together? Awesome. So let's go deeper now. Let's go deeper, right? Let's get a broader perspective. So in this scenario, this is the current state at which majority of the systems work. So one thing I'll advise you when you're targeting, let's say, a new technology or learning about a new technology, it's safer, or rather than it's best practice to approach it from an architectural point of view. This is the reason. Taking it from an architectural point of view allows you to be able to know at what point did it fail, at what point did it enter. Are we together, folks? So it allows you to understand this is how the data will flow from this point to the last point. Think of it like a circular flow of sort. Are we together? Stephen is in the lobby. Let me just allow him. Okay. So in this scenario here, what you're seeing is this little fellow over here. Are you able to see my mouse? My mouse move. You put a thumbs up if you can see it. Awesome. So this particular individual over here, let's call the individual Jacinta. Jacinta is over here. She wants to access her internet, mail, Gmail, right? So in this scenario, this is how the flow of the request is going to come out. We look at requests later on. I'm using a term request. I'm going to use a response, but it's going to be a home term as we go on. So we'll explain it later on. So in this scenario, Jacinta here is trying to access the Gmail account, right? So this is a process that happens behind the scenes. We have our long line, a thick long line over here. We call it the internet, right? But then remember, for Jacinta to be able to access that particular her email, she must connect one to the internet. How does she do this? How does she do this? So this is what she's going to do. One, she's going to put a request. Hey, so I'd like to connect to Gmail by placing in www.gmail.com, right? This then feeds in an enter on your browser, right? Immediately, this request is sent to the ISP. An ISP is an internet service provider. Those folks that give you net or give you access to the world now. Okay, think of it that in a simple way. So this ISP can be connected to multiple ISPs, and each ISP has their own server or can be connected to multiple servers again. It's a whole network within a network. Remember that. So this ISP says, okay, since you've given me this, is Jacinta wants to connect to Gmail, let's do this. Let me connect her to the main internet, right? And let's see whether I can find that particular server that hosts Gmail. Can I find it? Yes. So in this case, what the ISP does is it looks for one, you've given me www.gmail.com. Does it really make sense to me? Okay, I need to find my other computers, my other computer people, and understand that, hey, for me to find my computer person, I need an IP, an internet protocol. The digit we just saw, right? So what Jacinta fed www.gmail.com is known as a domain. Are you together, folks? Are you together? Have I lost anyone? If I've lost you, please shout out. Please shout out. Joseph, Geoffrey, Stephen, Lynn, Dorothy. Have I left either of you? Perfect. I like this space. Let's continue. Yeah. Okay, let's continue. Let's continue. So in this scenario, Lina said, hey, I want to access Gmail, right? Let me type it on my browser, hit send it. Then it goes to my ISP. The ISP says, okay, Jacinta wants to access Gmail, right? Let's do this. Let's connect her to the internet. Then the next thing is we're going to look for this particular server that hosts Gmail using the IP address, not the domain. Okay, so the domain is human readable. That is for us. But the IP address is not human readable. It's more the computers talking to each other. Remember, they don't know who we are. They can know who we are through our IP addresses, but not by our names. Okay. Let's proceed. Does this concept make sense so far? Does this process make? Yeah.
I'm a
Jacinta?
bit lost between. I'm a bit lost between. I've sent this request for to access the email.
Yeah.
Then it goes to the internet provider,
ISP.
which connects me to the internet.
Yeah.
What I don't understand is the connection between the internet provider and the internet. I don't know how they connect. Like, could you clarify a bit?
Okay, let me clarify. I want to think about it this way. Are you able to access Instagram without internet?
No.
No, right? So this Instagram application is hosted somewhere, right? So a place where this Instagram application is hosted is within a server somewhere around the world, right? So from this server, this is why you find we have like a whole server connected to a whole network, So remember, internet is multiple machines connected through various approaches, and now in a global scale. The internet allows you to expand your network. So in this case, think about it this way. At your very home state, you can connect your machine, your siblings' machine. Let's say you have 5 siblings. You connect your siblings, 5 siblings' machine and yours to one network. In that case, yes, it will be some form of internet because it has formed a network, right? But the question is, do you have access to a global scale? The answer is no, right? But you have access to within your local area, right? So now when it comes to now the ISP gives you access to the internet. The internet being the global space now. So in this case, you as Jacinta will say, I want Gmail. Okay, you connect to the internet through your ISP, right? Then the ISP says, okay, Jacinta wants to access the net. Does she have bandwidth? Does she has bandwidth? Okay, she has, right? Let's do this. Let's now connect her to the net because she's searching for Gmail, right? Once you search for Gmail, the ISP is going to send the request to the internet. The internet, what it's going to do is it's going to search for the Gmail, where the Gmail server is through an IP. Are you together, Jacinta?
Yes, yes.
Does it make sense now? Or can I simplify further?
Now I understand. Thank you.
Awesome. Okay. Thanks for the question, baby. So this here is your server, the ISP. So remember, this individual here, Jacinta, is known as a client. And the people who host our web, our applications, our web solutions are known as the servers. Are we together? Let's go on. Let's go deeper now. So this is like an explanation of what we've just spoken about, yeah? So you'll find data. What is moving here is data is traversing. So this the first request has gone all the way to the server. What the server does is it sends Jacinta a copy of Gmail to her local machine. That's why she can access it here. Are we together, folks? So once the request has gone through to the server says, okay, I have seen Jacinta's request. Let me respond to it by sending her a copy of this gmail.com. And I send it back to her. And that's when now we can access it. Are we together till there? Folks, are we together? Awesome. Thank you for that. So now in this case, you'll find data that is moving through the internet is broken down to small entities, something known as packets. The reason why it's broken down to small entities is you find it's easier to send small packets of data as opposed to large chunks of data. In the event that a small chunk of data is lost, rather is dropped, you can still at least get some snippet of that data. Are you together? Think about it this way. You're downloading a movie, yes, to the pirates out here. You're downloading a movie. You're downloading it from top. How many have experienced a scenario where you what do you call this? You're downloading the torrent file, then you start downloading the movie itself. It's like 1 GB and so 1.8 GB, let's say. From this 1.8 GB file, it goes until 1 GB, then it dies. It dies off. It says, oh my God, like, what do I do now? If you now try and open the file, yes, it will play, but it will play until a certain point. That is now the beauty of sending it in small packets. One, it's easier for it to send at least small chunks until the client gets it, the client or the user gets it. In this case, our client is Jacinta, or it can be anyone here. Gets it, then in the event that it drops off, it just drops off and continues sending whatever it can. Are we together till that? Okay, so I want to think of a scenario, yeah? I want to think of a very interesting scenario. You're watching Netflix in the office, right? You're there watching one of the craziest animes or listening to Alusa's latest song, right? The question is, your boss is on the other side, talking, doing some market research, market segmentation research. He's still using the same network as you, mind you. Would you like him to know that you're listening to Alusa's song or Salty Soul song? How many would love that? I know you can jump to it. You cannot come and dance to it with you, but the question is, would you like that? So happy. Yeah, I'm raising that. Who wants to try? Lorraine, would you like that?
No.
No, right? So there's something known as routers and packets. So remember, a server has its own IP. This IP is what is used to trace where the packet is going or where the packet is coming from. Right together. The packet meaning data. So as this data traverses, it has to pass through something known as a router or multiple routers. These routers tell it like, hey, yo, since you're going here, you have to go this place. You can use me, I direct you. You can use me, I direct you. You can use me, I direct you. That's the purpose of basically routers. Enable to like the packets to traverse through the net until it gets to the target destination. Are we together, folks? Are you together? Yeah. Awesome. Awesome. Let's continue. Let's continue. Does it make sense? We can be together, but it doesn't make sense. I just want to clarify. Does it make sense? Does it make sense?
Yes.
Okay, let's proceed. Let's proceed. So once you've gotten the buckets, most of the time, what you get from the servers is what is known as a component file or a resource. We'll look at component files later, but the package or that particular data packet you are seeking is known as a component file. It's really either package in form of a web page or data itself, or even a web page is data by itself. Let's say just a web page in short for a start. Let's go to the next. So here's the difference between like an IP and a domain name. So on the left side, what you see here is the IP itself, a series of numbers separated by dots and used by computers to identify each other. It would be really interesting if we could cram like IP addresses for like 10 plus sites. It's kind of difficult, a lot of brain power. There's an individual say there they love chess, old chess, chess under 1 minute, right? I think this can be an interesting challenge for you because it takes up some brain power. So on the right side, we see the domain name itself. This is something that is readable to us. So in the internet, there's something known as a domain name system, right? When you make a request, what is going to happen is it's going to go to your request is going to pass through the ISP, then go to a domain name system. The domain system is going to check one. You've given me this myexample.com. What is the IP of this? So the domain name system acts as a like an address book that contains the domain name and the IP addresses. The browser comes, makes the search, comes and checks what the IP of that particular domain name is, then now goes to the internet, sends that particular IP and starts searching for it until it gets it. Are we together, folks? Awesome, let's proceed. So that's like a basic level of just what the internet is. But then the question is, why internet? What's the purpose? What's the purpose? It's basically connecting the world. That's the key thing. So at this point, we've looked at internet in three perspectives: what, why, and how. Always break down a problem in that approach. What, why, and how. What is the internet? Interconnected machines. Two, why? How does it work? We've already shown you how the packets are sent. We have a client and a server all connected under one internet line or multiple internet lines. So it's just a network of networks, a complex network. Three, why is it important? Connecting the world. If you connect the world, you have more information, more data, more insights. It gets better and better. Both sides. It's actually your both experience. Both extremes. Till that point, are we together, folks? Questions till that point? Okay, let's proceed. Now let's take it deeper now. Yeah, we now look at now the web for the web itself. Yeah, so we've looked at the backbone of the web. What allows the web to run? Now let's look at the web itself. Something futuristic. Yeah, so the web is mostly composed of computers that are connected to the internet. In this scenario, we have on the left side, we have the client, and the right side, we have the server. The ideal scenario is always the client makes a request like, hey, I want to go visit Instagram, right? Then the server says like, hey, okay, you want Instagram? What about Instagram do you like? Let me send you the landing page with a bunch of images. Let's take it to TikTok. Let's take it to TikTok. I make a request to start the TikTok application. The server says, Lorena started there, has initiated that TikTok instance, right? Let's do this. Let's feed her with at least 5 images, 5 videos to capture and stick her here until she starts scrolling even on. That's what happens. This is how the web works. So let's go deeper. The client is usually us, our devices, our computers, phones, watches, anything that connects to the internet is basically our client because it's connecting to the internet through an ISP. The ISP now talks to them, is connected to the internet, then talks and searches for that particular server where the records are stored. And one way you can access it is through accessing software, web accessing software. in some scenarios, you find this a good example is Firefox, Mozilla, and all. That's what our client is, not the literal client we talk to every day. Are we together till that? Gideon, are we together? Okay, that's a good number. Let's continue. Let's look at the server. So this server fell over here tells us like, hey, you know what? I can store for you your things. I can be your warehouse and store for you your web pages, your sites, your apps. Then when you need it, I'll just send you a copy, but I'll remain with the original. But then once you're done, you can cancel it out. Are we together? So that's what the server does. The server plays one key role. One, link me to the database. Two, let me talk to this. Let me talk to this client and give them what they need. Not everything, but just what they need. Let's go deeper now. Let's go deeper. Let's look at parts of the web right now. So the web is composed of roughly those are 5 entities. We have an internet connection. Because for you to access the web, you need the internet. That's a primary thing. Then you have the TCP/IP. It's more of a transmission control protocol or an IP, internet protocol. The key thing here is how does the data travel across the internet? What is the medium? Which car am I driving? Which car am I driving towards this internet? Are you getting me? Then the DNS, the domain name system. So this DNS, what it works with does is it collects a list of a whole repository of domains. Each domain is mapped to a respective IP address. And now for us, we input the domain name. Then the computer will go to that DNS and do this. Search out of all the domains. Does this domain name exist? If it does, give me the value of the IP address. And I will use that to search for the respective server itself. That's still there. Are we together, folks? Perfect. Let's continue. Then we have HTTP and the component file. So HTTP is more or less, you see the way we are talking, having a conversation here. I'm using English to talk, right? If I transition to French, it's going to be different. If I transition to Chinese, it's going to be different. So the language I'm using to talk to you is now we call, the computers have their own language that they understand. In this case, leave alone binary and all. Look at the HTTP. I want to make a request to this server. How do I tell it I'm making a request? And how does it tell it it's a success? That's where HTTP protocol comes in. Are we together? One thing in React, there's some big words over here. One, protocol, domains, domain. So look at a protocol as that that rule book you were given the moment you walked into a school or a high school or some organization. Oh, please don't do this. Oh, please do this. Oh, please wear this. Oh, please do this. Like a whole procedure to which you as an individual must adhere to be able to perform optimally or fairly optimally or beyond optimally, I guess. Okay. Then you go to component files. Component files, that's a very huge term, but it's what is used there. So I'll simplify it. A component file is basically, think of it like this. Your ice cream place by your neighbor sells ice cream, right? When you need ice cream from him, you give him a call, you send him money, then he says, hey, since you've paid for this ice cream, I'll bring it to you. So as he's dropping that ice cream to you, he uses a particular channel, right? Then the conversation you are having, like, hey, oh, I need ice cream. Please give me ice cream. That's now is a HTTP. He's using a HTTP approach to talk to you as the client, you as the neighbor are talking to your neighbor who's selling ice cream, telling that, hey, I want you to give me ice cream. Then the neighbor is like, how much? It cost 10 shillings. Okay, let me send it to you now, ASAP. Okay, have you received? Yes, I have received. Okay, can you send it? Okay, let me send it to you. The neighbor quickly rushes from their house to your house, brings you the particular ice cream, and voila, that is your component file. In this scenario, fine, the component file is composed of taking the ice cream analogy. You have the cone, you have the ice cream, all milky, all tasty and all, right? And the sprinkles as well. That is your component file. In a real world scenario, your component file is mostly composed of the code file and the assets in most scenarios or some scenarios. The code file is basically your source file. Where your code is, where you wrote your code, your beautifully written code. Two, the assets are what you need to make or rather make that application better. Let me put it this way. Let's say you're going to work. Let me take it back to our ice cream guy. For the ice cream guy to be able to make ice cream, he or she needs, for example, let's say they're making it from scratch. They will need packing containers, they will need cones, they will need a fridge, they will need electricity, they will need, let's just say 4 of this. Those four entities are his or her assets that he will use to compose or make that beautiful ice cream and make it as tasty as possible. Are we together till there, folks? Does it make sense? I just need to know if it makes sense. If you have a question, please ask. I don't want to leave anyone behind. Please ask. Perfect. Lynn. Awesome. Hezekiah and Stephen. Are you guys okay? Awesome. Let's proceed. Let's now go deeper, right? So we've come from our internet. We've learned how it works. We're not through the internet. We now bring in now the web. The web now is the internet is the backbone of the web. We've spoken about the web. Let's take it deeper. How it flows. Okay. So this is you, and you've already made your search on your browser. So immediately you'll find starts off with the browser. You go the browser, you make the search saying, oh, I want to go to gmail.com. So you type www.gmail.com, then immediately you press enter. It clicks search, right? Once you set it to search, what it does is the browser goes to the domain name system and searches for the target IP. Sorry for that, target IP. After it gets the target IP, it now proceeds and sends a HTTP request message to the server, telling it like, hey, yo, this guy, I've requested for this and I have found you. Please send me a copy of that particular platform or give me a copy of the resources that I need to run. Then the server will be like, okay, we've made this request. Is it from the right place? Is it well authenticated? Is it done in the right way? Okay, if it's okay, then I'll say, it's fine. I'm going to send you all this. But then for you to ascertain that I have confirmed this, I'll send you a success message. What you see at 200, okay. Are we together, folks? We learn about it later. For now, just know the server will tell you that it's a success. After the success, I'm going to do this. I'm going to now send it back to the client and tell them you're on the right track. Your goods are on the way. Positive. Okay. And finally, once it's done, it now sends the package itself. Once it's sent it, what your browser will do is it will take those packets, consolidate them to your data or rather web page, and voila, you're paid. Are you together till there, folks? Are you together? Awesome. So remember, you started off the internet, the backbone, you've gone to the web, let's go deeper. So these are just some definitions. I know majority of you wanted to ask or couldn't have a chance to ask. So the DNS is the domain name system. This is TCP/IP, transmission control protocol, and intermittent protocol. This is your car. You're the one which uses as your conduit. HTTP is the hypertext transfer protocol. This is more or less like the language we use to talk to the server. Me as the client, you as the server. How are we conversing in English? Are we together? So thank you to note a few terms as we proceed. You might not encounter them at this very moment, or rather now, immediately, but you will encounter them in the future. One, a web page. A web page is that thing you see on a browser. A website. A website is more of a collection of web pages. Multiple pages relate to you, something that allows you to achieve a certain purpose based on the creator's ethos. Are you together? Then you have a web server. A web server is more or less like a server that hosts your particular website on the internet and makes it accessible to everyone. Then a search engine. Search engine, I think everyone is familiar. It just answers the question. it's like a curious puppy that is waiting for you to throw that particular frisbee so that it can run, catch it, bring it back home. That's what a search engine is like. So it's just curious, like it's burning out of you. It's like, hey, give me something to search. I go to the internet. Are we together, folks? Then as it goes to the internet, it goes to the web server. The server says, I have found you. Feed me my first instance, or rather a copy of that web page. Okay, let me serve this web page to this individual. It's served. Then if the web page, if it has multiple web pages, it's now formulated known as a website. Are we together, folks? Are we together? Perfect. Perfect. I hope it's making sense. And I hope it's making sense. If you have any challenge, please don't hesitate. I'll answer it. Let's continue. So now we've spoken about the internet and the web, right? But the question is, the reason you learn stuff is not just to learn and be fancy about it, like I know, right? The key thing about learning is we need to solve a problem. And this is the point at which I'll take you back to what is known as SDG goals. There are a number. Pick one, try and solve. And try and solve one that is you can resonate with at an intimate level. One that, let's say, takes you back home in rural area, or home in rural area, or just home in school, or anywhere, just home, right? Yeah. So in this scenario, the key purpose of learning, what you're learning here, is to build a backend system that can support data integrations and all. So remember that you're learning to solve a problem, as you said. In this scenario, we're going to look at what you're looking at is now backend development. How do we develop those softwares that rest within servers that can be accessed by multiple people from a global scale, right? This whole concept of developing systems can be broken down into a number of phases, but I'll narrow down to two. You can either develop a platform that is just meant to connect to a database, right? You can either develop that platform, or you can develop a platform that harbors the database itself, does the computation, does the analysis, or the heavy processing, then sends it to the user or the client. Where the server is and the database is, where the API in the database is, that is your backend. Rather, that is what you call the server side. Where the user is, where we are accessing the medium to entry to any client, that is your front-end part. Are we together clear? Are we together, folks? Okay. Let's continue. So, okay, this is a lot of text, but I'll just simplify. One, this is also called backend development. Two, it's able to relay. One, it's able to give data to the client based on their needs. Three, it's also able to give data to the client based on their usage. Are we together? This is now where you start adding more functionalities at a later stage. Let's say you're a person who loves to shop about puppies, puppy feeds, cat feeds, basically pet feeds, right? I will only serve you products related to your animals. I won't serve you products related to motorcycles, to vehicles. No, I will lose you. That's a scenario. So the server side basically asks the question, since I have all these resources within me in my database, how do I expose them to the world? And how do I give them, right? So I want you to think of this scenario. I know everyone, eating is very important. If you don't eat, you die. If you don't drink water, you die. So I assume everyone has gone to a particular eatery or a particular restaurant, right? When you go there, I want you to imagine yourself just walking all through them. You walk through the restaurant, you have a seat, place your order, at times pay before or pay after, right? So once you've done that, the food will be brought to you by a waiter. You will sit down, you will eat, and you will leave. But the question is, where did the food come from? How was the food made? Are we heading somewhere, folks? Are you heading somewhere? Okay, let's do this. Let's go deeper. Let's make it more vivid. Okay. This is the scenario I've just spoken about. We have you. This is you and your fellow. You, either you and your person. You're eating a prepared meal, very good meal, right? Then here we have a waiter or waitress. They tend to bring food from the kitchen to you. And the chefs here in the kitchen, we have the top chef over here, and these are the cooks, other cooks. This is the it's called the head chef, and these are other chefs. So they follow the lead. Whip that cream properly. It has to be smooth. So here the cooking is done. Once it's done, it's taken to the waitress. The waitress, what she does is she checks out, oh, who has ordered for this food, then takes them to them. All right, together, folks. Higher. Let's go deeper. Let's go deeper. Let's now relate this to our whole server side and basically the backend architectural system, right? Let's go deeper. This is my analogy, right? This here fellow take the role of a client side. Are we together? I am only there to interact with the last product. I am not there to manipulate or interact directly with the database. I want to see the data. That's the thing. The waiter, the waitress, the waiter, and the kitchen rest on the server side, rather in the server section. The waitress does the purpose, serves the purpose of linking this particular cook, the kitchen, to the client, but giving them a final product. Are we together, folks? In this case, I will cook omelette, take it to them. Take it, the waitress will come and pick the omelette and send it to them. In some scenarios, you find people take raw eggs. In French, they say à votre goût, to your taste. So like, that's another scenario. So this API rests on the server. This particular database, this is the database side where we have all the data being manipulated here. Once it's done manipulated, it's sent to given to the waitress. The waitress is the API in this case. I know API is a big word. We'll interact with it later on. Now just look at it from a high level perspective, like how does it work? Understand how it works before we go to now the deeper sections. Okay, remember we are climbing our mountain step by step. We've already done the internet. We're going to the web. Now we're going to the server side. Are we together? So now we're at the server side. Till this point, does it make sense? Perfect. Let's continue. So this is basically the server side. So there are many forms of architectures that are used within the backend systems. In our scenario, we're going to look at a client-server architecture or a model, what they call model. Yeah. So it's composed of three bits, three parts. You have the client side, you have the server side. Just a second. The client side, you have the server side, and you have the network. The client side, as we already said, requests for whatever resources that they need, then is given the data and it views. The server side has direct access to the database, and from that database, an API talks to it. An API request is made from the client side, and the client sends that request telling the server that I need this data, please give me this data, and it gives them. So basically, you log in onto TikTok. TikTok says, oh, Geoffrey would like to watch TikTok videos based on sports, right? Okay, this is nice. Give me anything related to sports. Let me send it back to him. That's the same process. I request something and a response is given. That language, the HTTP language, they call it the language for computers, rather the loud language for computers. Let's proceed. Now let's make it even more deeper or vivid, right? Look at it from a perspective of waiter. Now let's now put in the actual entities, yeah? So in this scenario, I want you to notice four entities here. We have the client side, we have the server, we have the database, and we have in the background the internet. My assumption is you're already connected to the internet, and this is you. This is Stefan. Stefan would like to connect to the internet, not even connect to the internet, would like to watch a game. I came of rewatch Manchester United and Liverpool's game and see, Manchester survived. Okay, this is interesting. Let us watch this game to verify because the last time Liverpool and Manchester played, they were beaten 7, like a week. That is serious. Then I find this is Stephen over here. He makes a request to the server. The server now says, okay, you people gather up. Stephen wants to watch a review of the Manchester United game. Let's do this. Do we have it in our database? If we do, let us go fetch it. So they check whether they have it in the database. They have it in the database and say, yes, we do. Sorry, yes, we do. So let us go fetch it. You go to the database, get it as a record, gets the response, then returns the response to the client side. So in this case, I want you to notice two things. We have a request, we have a response. That is one. Another thing to look at into is one, we have a server, we have a database, and you have the client. Are we together till there, folks? Whom have I lost? I lost anyway. Right. Let's move. Now let's go deeper. Let's make it more vivid. So one advantage about this is there's a central point of failure and there's also a central point of success or access. So you find there's only one server. And through this server, you can access only the client can talk to this single server. You can have more than one client. You can have multiple clients. Two, you have security. So security is centrally administered. Like you don't need to distribute your security to different entities or different servers. You just need to implement it at one point. Performance is actually guaranteed, but it reaches a point where the concept of isolation becomes paramount. This is something that you learn later. For now, I'm just easing you. Okay. Let's proceed. It's easy to scale out the number of clients and servers repetitively. This is more or less like, can I expand my reach? Can I balance the load? Can I have more traffic to my platform? Such questions. Okay. Proceed. Still there. Together, folks. Just waiting for you. Yeah. We're together. This is good. This is good. And let's continue. So I'm about to tell you a story about the language of the client in the server. The language that they speak is known as HTTP, Hypertext Transfer Protocol. Let's see what it's about. So here, hypertext basically refers to a text that contains links to other text. So look at the keyword hyper. Hyper comes from the word or meaning of what is this thing called? Over and beyond, over and above. Meaning, it's not just that text, there's more to that text. And maybe I can get a deeper text. Hopefully not infinitely. But that's the idea. Transfer basically, hey, since you're talking about text and all, what can we talk about it? How can we transform this to a language? To which me as a client and you as a server can have a conversation. Okay. Then the protocol, as I said, let me take you back to high school or primary. How many recall almost every assembly session? There's some teachers who would come, stand erect, ties all suited up and all, looking really neat. And they will all start by all protocols observed. How many recall that? How many? Lorraine, Geoffrey, Lynn, Joseph. Do you guys recall? Did you guys experience that first of all? Besides recalling, did you guys experience that? Okay, Gideon, it seems you didn't experience this. Okay, a protocol is basically a set of rules telling the people that, hey, what's up? I have followed all your rules. Please do not cane me. Please do not finish me. That's basically what you're telling these people. So here, HTTP is more or less like, hey, I want to talk to you. But as I talk to you, please follow my rules of engagement. 1, only use get, post, put, patch, delete. We'll see that later. Not wrong. But get the context. Are you together? Okay, let's proceed. So here, just to take you back a little bit, the green arrow, this green arrow acts as our language, the HTTP language. So here you are, you had already requested for, Geoffrey requested for videos related to sports, right? Or let's say people are awesome videos. So the server got it, then returned it, right, together. So this here, what you see here can be a possible connection of clients here. One of the clients is here, right, together, folks. Right, people out together. Together. This is good. Okay, so let's look at the properties. So HTTP basically is just a network protocol that allows transfer of hypermedia documents on the web between the client and server. So yeah, hypermedia is a very big word. It's so fancy. What does it mean? 1, over and beyond. So is this media you're sending me? Can I click it and receive another media? Well, how deep can I go? Such questions. Can I get more content? So that's the concept of hyper. So mostly when using HTTP, it tends to send you text, more or less text documents of sort. Are you together, folks? Okay, awesome. So HTTP basically acts as a foundation of data exchange. Big words. This is how majority of the computers talk to each other. This is the medium of talking. And you find that the conversation always happens between the clients and servers. But one caveat is you cannot do a stream of data using HTTP. Are you together, folks? Together? That's something you need to note. I know the question you have is, what is a stream? Who can try out? Who can try what a stream is? Anyone? Anyone? Dorothy, you want to give it a try? Geoffrey, Lynn, give it a try. What is a stream? How many people know what a stream is? You can raise up your hand. You can use a different emoji to say I'm lost, things like that. Use emojis to express. It's just that I can't see. I can't see it. Just use emojis to express. Oh, okay, nice. Lorraine, do you know about it? You will. Oh.
I'm going to give it a try. So a stream is like bulk form of data, or data that's coming in groups.
In groups.
Yeah.
Close, nice try. That is perfect. Nice try. You're close. There's just a keyword you're missing. Just one keyword. Someone else, give it a shot. One more person.
Yes.
Yeah.
Maybe a stream is something, maybe a stream of data. Data moving in a particular direction, like following each other.
You're on the right track, but there's a keyword I'm looking for. Jacinta. Nice one, dude. Nice. That's a good attempt. Nice one. You're actually all right. It's just one keyword. Yeah, Jacinta, give it a shot.
From my understanding of the word stream from just general like English, maybe data in a sort of continuous manner.
Perfect. That's the keyword. Hezekiah got it. I just saw it. Apologies. Nice one, nice one. I love the spirit. So Hezekiah and Jacinta, you got it right. The keyword is continuous. So when data moves in a continuous flow and it's vast in nature, that means it's close to infinite, right? And this scenario, look at HTTP. When it comes to HTTP, you're having a conversation with someone. Think about having a conversation with someone that can't stop talking, rather can't stop commenting, is continuously and it's endless. Would you be able to continue that conversation? The answer is no, right? So I want you to look at it this way. If the data is continuous and you're trying to use HTTP, you're trying to talk to the database is giving you a response with request and response. We don't have time for that request response. We only have time that give me the data, continuously give me the data in form of a stream. This stream is probably infinite. That is the difference. Are you together till that, folks? Perfect. Oh, that's good. So we spoke about hypermedia, right? Hypermedia is just like above and beyond. With this media that I got, can I print? Can I click on that media and get more media? Can I click on that link and get another link? That's a concept about hypertext or hypermedia or etc. You'll find even hyper audios, hyperlinks. Yeah. So all this allows you the hypermedia, the hyper dot allows you to now facilitate the relay of content easily and exploring of content. That's why you find when you go to a platform, you won't only just stay on the home page. You click onto an image, it takes you to another page. You click onto a button, it takes you to another page. You click onto an icon, another page. So it's going above and beyond what it does. That's the main gist about hyperfit. The hyper bit. Okay. Let's go deeper. Let's go deeper. It's getting interesting. It's getting more interesting. So now we have here what you know as a simple URL. What you see here. We have the HTTP, then you have the domain name, right? This HTTP, what you see here, this is known as a scheme. Right together. In this scenario, I want you to look at it this way. When it has the HTTP without the S, it transports the data over an encrypted connection. Are we together till that point? Encryption, and I repeat, are we together till that before I explain something? Perfect, nice. So, you know, the funny thing is, I still repeat the past statement. It's weird how sometimes some innovations in the tech realm come about as a result of army research or research from the army. So you guys remember, I think it was World War II. Those people who love history or have heard about it. World War II, World War I. There was a battle between this Germany and some country, some country I've forgotten. So the key thing was they would cipher. By cipher, I mean they would encode their whole conversation over the landlines. So when you try tapping onto the landlines to listen to it, you wouldn't understand what they're saying, or it's called a Morse code. You wouldn't understand what it was interpreting. So there's a group of individuals. They'd only have 6 to 12 hours to interpret what the message that was sent meant. So imagine the fate of the world is dependent on just 12 hours of interpreting, trying to figure out what did this enemy say. See how crazy it is. Let's take it deeper. So if with that result later on, a group of course mathematicians just decided, let's come together, form of like a group. Let's be working on this 12 hours, we split our brains together. And they did so. So you find later on they came about known as Enigma, the Enigma machine. This Enigma machine was able to take in whatever message that it got and to decipher it and tell it, hey, this is where the next attack is going to be. Run, my friend, run for your life, run. And this is how this works as well. So that's why like the birth of encryption, ciphering, asset, like not just asset, but content security and all came about, started rising. So in this case here, you find if it doesn't have the S, it lacks the concept of being encrypted. C is not safe for you, nor the person you're building it for. Or your platform. Till there, are you together? Are you together? Awesome. Continue. The next chapter. So we've introduced the HTTPS. It gets better now. So remember, HTTPS is known as a scheme. The rest is the domain, basically, the domain, right? Here, we access the resources and it's transported, remember, it's transported over a secure TLS, transport layer secure channel using HTTP protocol. So that's what the S does here. It's just to tell it's more secure. All right, together. So TLS will come to discover that it's also, it formerly used to be known as SSL. If you've done development or you've interacted with some devs before, you'll find a common error, or rather a periodic error that they tend to receive after some time is SSL certificate has expired, things like that. So it questions you. How I was identifying that you are okay is now disappeared. We need to now renew that certificate. Are you together, folks? Let's go deeper. Oh, okay. Yeah, okay, I think I've explained this. HTTP is more of textual. All communication is done through plain text. We'll be able to witness this when you now start handling APIs. Okay. So it's stateless. State is a term that you're going to encounter in your whole programming career or development career. I want you to imagine or pick the closest element next to you, be it a bottle, be it a pen, be it a paper, be it a book. The position, put that book in a particular position or bottle in that particular position. Do not move it. At that very point, that is the particular state of that bottle or entity. If you move it from point A to point B, you have changed the state. So some platforms, you need to manage the state. Reason being, it reaches a point where mostly in front-end applications. It reaches a point where you want to handle, you make your application handle a non-internet connected area. So you need to cache the data the moment you get access to internet, provide it to the user, wait for the internet to come, update it, provide for the user. So that is a form of state. When it comes to HTTP, it's more or less stateless. There's no need of being aware of what I sent to this particular IP. There's no need. Plus, I think it's even strenuous in terms of performance. I don't need to know like you sent a whole GB of movies from this client to this client. No, all I need to say that you finish this transaction. You're done. Let me start another one. Something like that, as simple as that. Are you together, folks? Till that point, I just need to ask one question. Do you have any questions? Any question that you have? Okay, let's continue. So here we already spoke about transport layer, not a laser. Sorry, that's a typo. It's a transport. It's a transport layer security, formerly known as a secure socket layer (SSL). So in this case, it's usually protocols that are used to transfer or communicate securely across networks. It prevents the concepts of eavesdropping, tampering with message, or payload injection, things like that. So it's very important to have on your platform or your sites. Okay. So the next thing is, wanted to look at how do we now talk to the interact with the database, how do we handle requests? Basically, how do we now create that conduit that is going to handle all these processes? One, talk to the database. Two, respond to the server. Talk to the database and respond quickly. Three, check out the status of various clients or servers as well. Let's proceed. So we have like a number of server-side languages. We have JavaScript languages. We have JavaScript, PHP, Python, JavaScript, Java, JavaScript, PHP, Python. We have Ruby. We have so many. We have so many. But one thing I'll tell you is there's not one is better than the other. It's a question that you find in a number of channels telling you that, hey, the top 10 languages to learn, the top 10 frameworks to learn, things like that. I think the metric that you can use is, one, how long has this particular technology been in the industry? If it is new, my friend, be diligent. Because one, the support is not there. It's not as hot as it is. If it has been there for a very long time, that means it has undergone so many iterations, so many updates on the structure, on the code, on how it's written. Basically, it has gone into iterations or revolutions, if I put it. And it's easier to handle that because even there's a wider base of support. Any technology you look into or dive into, look at those two metrics. One, how long has it been there? Is the support present? Then now you go and ask yourself the question, can I really solve a problem? Or can I identify a problem and solve it? Because when you go outside here, people don't care about this is the current problem I'm facing. This is the current challenge I've seen. How I solve it doesn't really matter to how it's used. Does it make impact? So irrespective of whatever language or tool you choose to use, the question is, can you solve the problem? It is a main question. In this course, you're going to handle a tool known as, you're going to use PHP. And you're going to go with Laravel as the framework of choice. It has the most beautiful, if I may say, documentation. It's very simple, it's well styled, it's very definitive. I would go for Java, JavaScript, and Python, but for JavaScript is very diverse. You're going to interact with it in your front end, hopefully. So the one thing I love about JavaScript is it works on top of an engine, what is known as a V8 engine. You'll interact with it later on, either on the browser or outside the browser. So in our case, we'll focus on PHP. Are we together, folks? Awesome. So without no further ado, I think that is the end of today's session. I don't want to bombard you with a lot today, but it's the end. However, I have some tasks and materials I need to go through before tomorrow's class. One, I want you guys to create a Medium account, GitHub account. One, we'll be writing based on my sessions. We'll be writing weekly articles. So we'll have a session today and a session tomorrow, right? Then you'll write an article, post it, share it. I will read it, and I will put my reviews. The purpose of this article is to enable you to understand what you learned, and two, you need to teach someone out there what you've learned. So in this scenario, I'll advise you use a technique known as Feynman technique, whereby you break down a problem to a point where you can explain it to a healthier. So whatever I taught you today, or whatever you're going to read further and beyond, at the end of tomorrow, you'll have more content. Consolidate all that. Write an article, post it on Medium, share it out. I will read, and I will follow, and I will comment. Right, remember? Two, I want you to create a GitHub account. How many don't have GitHub accounts? This is good news. Almost everyone. Oh, Stephen, nice. Okay. You can create a GitHub account. We'll use that for version control. I will introduce you to version control progressively. I want to take a lesson, teach you on it. I'll just introduce you progressively. So don't worry about it. It's going to be fun. Think about who hasn't watched Harry Potter? Anyone that hasn't watched Harry Potter here? Or the concepts of Doctor Who? Doctor Who? Doctor Strange? Oh, okay. Anything related to time travel? Anyone? A movie or something related to time travel? The Flash. Who has watched The Flash before? Let me rephrase. Who hasn't watched The Flash? Who hasn't watched The Flash? This is good. So everyone has watched The Flash. So the Flash can run so fast that he can go. Link, you haven't watched? Okay. The Flash is like a superhero that can run so fast to the point that he can go through time, back in time, and forward in time to the future. So now in this case, he just runs very fast in the opposite direction of the rotation of the Earth. Then it now slows it down, and he's able to jump to the other side. So in this scenario, that's what Git and GitHub is going to do for us. We'll be able to store our code somewhere at a point in time, and we'll be able to jump forward to check. We'll basically jump backward. In your scenario, you don't jump backwards. We'll be able to go back in time to see, oh my God, this is the kind of code I wrote at this point. Let me improve. Oh my God, I was writing really good code. Let me continue. Things like that. And you're able to get, store your projects, save them, and also share them as well. That's in terms of tools. I'd like you to how many are using Mark ecosystems? Mark ecosystems, Mac OS, MacBook. How many are using Linux? Linux users. How many are using Windows? Oh, you have one Linux user. Two, three. Okay, that's good. Okay, this is good. This is good. So, if you're using Linux, no need of installing Git. It's already there. But if you're using Windows or macOS, you'll have to install the Git. What you see here. Okay. The other one is all of you should install VS Code. It's lighter and it's more easier to use and interactive. Yeah. Gideon, you okay?
Hi, Joseph.
Hi.
Allow me to interject. So I wanted to remind you to put the task on the LMS as well as the
Yes.
content.
Okay, that's okay.
Yeah,
That's okay.
also for the participants, you can log into LMS. You'll be able to get the recording for the class and the task as well as the content that Joseph is going to update. Thanks.
Okay, thanks for that. Okay, thank you very much. George, your hand is still up. Gideon, your hand is still up. Do you have a question or do you have a point or concern? Oh, thanks for that. So kindly download this, and as you heard, you will share all this. Then, these are reading materials you can go through. They're not complex. They're actually fun to go with or rather read. One, it talks about the web server, where I host my web applications or web platforms, right? Two, we go to a backend roadmap. This is a definitive, highly in-depth roadmap for a backend developer, through to the point they transition to a DevOps engineer or developer, we call it. Three is the OSI model. When it comes to now tech or development or just any technology, you don't need to know you need to know everything really, really well. You just need to understand how it works. Hence the statement I made earlier. Tackle it from an architectural point of view. And that's the purpose of the OSI model. It's going to tell you how the networking layer works, basically. For those who are interested in TLS and SSL in terms of security, I have something there for you as well. Okay. Then, with no further ado, I'd like to end today's session and If there are any questions, concerns, please read them. I will answer. For tomorrow, we'll go to we'll handle. We're going to start fundamentals of PHP. We'll just read code. We'll do some fundamentals of PHP and yeah, fundamentals of PHP and some simple programming, basically. Yeah, basically that. So questions, please ask your questions. No questions? Levine, Jacinta, Geoffrey, Joseph, Hezekiah, Stephen, Gideon, Dorothy. Questions? Okay. Then I guess that's the end of today's session. Thank you very much for coming. Thank you very